The next part that we're going to do with trigonometry are the trig identities. So there are going to be 7 identities that we're going to do. The first one is by far the most important. If you're going to remember just one, this is definitely the one you want to remember. So what this is coming from is the unit circle. So go back and let's think about the unit circle. So the unit circle was a circle where the radius was 1. So the distance from the origin to any point on that circle was 1. Also, if this was my angle, here was theta, I knew that this point was cosine of theta, sine of theta. So the x-coordinate was cosine, the y-coordinate was sine. If I make a triangle here, and I'm going to kind of blow it up so you can see what this is looking like. I had the hypotenuse was 1, this was my theta. My x-coordinate was cosine, so this length is cosine theta. This length was sine theta because that was my y-coordinate. Using the Pythagorean theorem, you know that a squared plus b squared is c squared. So if I use that here, I'm going to get sine of theta squared plus cosine theta squared is 1 squared. Well, 1 squared is just 1, and also we write this a little bit differently. So this is our first big identity. Sine squared theta, which this is how we write it, this means sine of theta squared, plus cosine squared is 1. So this is identity number 1. I'm going to put a box around this. This is absolutely the most important one. So anytime I have an angle, I square the sine, square the cosine, and get 1. So for example, I could say that sine squared of, pi over 12 plus cosine squared of pi over 12 is equal to 1. As long as these two angles are the same, and I'm squaring the sine, squaring cosine, I will always get 1. The second big identity comes from dividing this equation by cosine squared. If I divide this equation by cosine squared, I'll get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. Sine squared over cosine squared, well, remember tangent was sine over cosine, so this is tangent squared. Cosine squared over cosine squared is 1. And remember, 1 over cosine was secant, so this is secant squared. And that's our second equation. Third is, what if we take our first equation, call it star, if we take star and divide it by sine squared. So I'll have sine squared theta over sine squared theta plus cosine squared theta over sine squared theta is equal to 1 over sine squared theta. So what do we get when we simplify this? Well, sine squared over sine squared is 1. Cosine squared over sine squared. Remember that cotangent was cosine over sine, so this is cotangent squared. And 1 over sine squared, that's going to be cosecant squared. So cosecant was 1 over sine, so 1 over sine squared is cosecant squared. So those are our first 3 identities. Again, the first one is absolutely the most important. The rest of them come from this. Fourth identity that we can look at are the complementary angles. So what this is coming from is from a right triangle. If you think about a right triangle, and this is my angle, theta, this angle here has to be pi over 2 minus theta. Because if there are 180 degrees total, which is pi radians in a triangle, I have to have this is pi over 2, we already have this is pi over 2, so this has to be the complement. Also, if I look at, let's say the cosine of this angle. What's the cosine of theta here? Cosine of theta is going to be b over c. What's the sine of this top angle? That'll be opposite over hypotenuse, so b over c, which is the same. So cosine of an angle is going to be sine of pi over 2 minus the angle. Along with this, I can look at sine of the angle. So what's the sine of this angle? Well, that's going to be a over c. And what's the cosine of this angle? Also a over c. So sine of an angle is going to be cosine of pi over 2 minus that angle. So what does this mean? It means if I have an angle and I'm taking sine of it, that's the same as taking cosine of pi over 2 minus the same angle, and vice versa. These kind of go together. The fifth thing we can look at are the addition formulas. No, it's not really true that you can just add angles and just kind of say sine of an angle plus another angle, you just add them together. That's not entirely true. But what you can say is that sine of x plus y, it's not quite sine of x plus sine of y. It's sine of x times cosine y plus cosine x times sine y. So you are going to have two terms, but you have to consider that you're taking the sine of x and the cosine of y in the first one, cosine of x, sine y in the second one. Along with that, I could have the corresponding cosine. This one's going to be cosine x times cosine y minus sine of x times sine y. So these are your two addition formulas. If you're saying sine of two things that are being added together, you could reduce it in this form if it's easier. If you have cosine of two things that are being added together, you could reduce it into this form. Next, I have the double angle formula. And there's actually going to be 4 that come from this. So the first one is that sine squared of an angle is 1/2 times 1 minus cosine of 2 times that angle. So sometimes it's maybe easier to solve cosine of 2 times the angle, and then I could figure out what sine squared is. Corresponding to that, cosine squared of an angle is 1/2 times 1 plus cosine of 2 times that angle. I could also say that cosine of 2 times an angle is cosine squared of the angle minus sine squared of the angle. And then lastly, sine of 2 times an angle is 2 sine of the angle cosine angle. Now when are you ever going to use these? Sometimes it might be a little bit easier to say find cosine squared of an angle and sine squared of an angle. If you can figure out those two, then you can figure out cosine of 2 times an angle. These are not necessarily things that you need to memorize. The ones that you do want to know are the first one, absolutely, and then know how to get the second too. So 1, 2, and 3 are the ones that are super important. These are more things that you shouldn't just memorize, but kind of know how they all work and kind of be comfortable with what they look like.